dealing with a sphere.
I got it right. No, I'm right.
A sphere is a solid, which means it's a three-dimensional figure you can touch with your hands. It is then all of the points that are a fixed distance from a specific point to center that we've talked about. It gives you the shape of a ball. Now that fixed distance is your radius, and that single point is your center. Really? That kind of makes sense.
What?
Because it does make sense because you're talking about the scale of a mountain being like, what is our tallest peak? Here in Lane, it's not what it's maybe. I don't even know what the tallest peak is, so I can't even go from there. But then the Earth itself has a diameter of 12,800 kilometers.
Are they sure?
Compared to the mountain, it's like almost nothing. Okay. So now, back here. We have two theorems that deal with
Hey, you know what?
a sphere. One of them is the area of the sphere. The area of a sphere is that outside of it, the part of that ball that you could paint. That's the area of the sphere. Notice there is no such thing as a base or a lateral surface. A sphere has one surface. And when we're talking about the area of a sphere, we're talking about the area of that surface. Just like with any area, it'll be in square units. Okay? So the area of the sphere is 4 pi r squared. The volume of the sphere and the volume of the sphere is cubic units. It's basically how much sand would that ball hold. Okay? The volume of the sphere is 4/3 pi r cubed. That's the volume, and it's cubic units. So our area is 4 pi r squared. Our volume is 4/3 pi r cubed. These are our two theorems. 12.9 and 12.10. Now, if we're talking about a sphere, then there's really only one unit of measure. That is the radius. But we can get a right triangle in a sphere, and here's where it comes from. If you have a sphere and you pass a plane through that sphere, now on the Earth we have planes passing through this sphere of the Earth. They form our latitude lines. Okay? So we could have a latitude line right here that actually is a flat surface that passes through the Earth. Okay? Now that latitude line has a radius. And if you take a look at the radius of the Earth, which is r, and I drew it in black there, and the distance between these two centers, this would be the distance that plane is from the center of the Earth. And then the radius of this latitude line, which we could call x. So we have a distance that the plane is from the center of the Earth or from the center of the sphere. And we have a radius, d squared plus x squared equals the radius of the Earth squared. Now, you could also think of this as a fishbowl.
Oh, I like fishing.
We have a fishbowl,
Oh, no, do it.
and a lot of times a fishbowl is pretty spherical.
I don't like
You have a surface of water in that spherical fishbowl.
drop fish. Yeah. What? I would not catch that as a target.
Okay? We might be interested in what is the radius of this surface. Well, if we know where the center of the sphere is, and we know the distance that that water is from the center of the sphere, then we can use this formula right here, knowing the radius of the sphere, to find what is the surface area of the water. Why would we want to know what is the surface area of the water? How does the fish get oxygen?
Through gills.
Yeah, but how does the water get oxygen?
From the air.
From the air. How much air touches the surface of this water is exactly how much air can transfer into the water.
A lot.
You have to have a certain surface area in order for the fish to survive. So if you had a really small opening with a very small surface area, there would not be a whole lot of oxygen transfer between the water and the air. Okay, so that would be a reason you might want to know what is the area of that surface